All right, geometry. We're moving on to section 9.4. This is probably one of my more favorite sections of chapter 9, just because inscribed angles I like to do, and I think they just make sense in a circle. So I hope you like this section. I'm going to go to this diagram over here first to start with, and we're going to talk about inscribed angles versus something called a central angle, which is what we've done before. So before, what we would do is like arc QS would be separated off by a central angle, and central angle because its vertex is the center. And we know that if, like, let's say that this was 80 degrees, let's say, okay? If that's 80 degrees, then this arc is also 80 degrees. Like, the arc is the same measure as the central angle. But here's the deal. If we're talking about this angle instead, which is called an inscribed angle, let's label that. So this is the central angle because it's in the center. So central angle, and this is an inscribed angle, okay? What is the measure of this angle right here? Like the measure of the inscribed angle? Well, it can't be 80 degrees because 80 degrees is a wider angle and this is like more narrow, right? The way that I think about this is like, this is my bow and arrow right here. Let me draw a better picture. This is my bow and arrow here, and I'm taking this and I'm pulling it back, getting ready to shoot my bow and arrow. It's kind of like pinching that back, you know? It's going to make a more narrow angle right here, okay? So it can't be 80 degrees, but what is it, okay? The rule is that this is always half this angle right here, if it's inscribed, meaning it's touching the opposite end of the circle. It's going to be half of what the arc is, or half of what the central angle is. So this guy all the way to the back here is going to be a 40-degree angle. And that's just the way that inscribed angles work. Obviously, he's got to be a smaller angle. This is not as wide as what this is. And the rule is that you just split it in half. So it's kind of a nice, easy thing to follow, okay? So central angle versus inscribed angle. The central angle is double the inscribed angle, or inscribed is half of the central angle. And it doesn't matter whether your central angle goes through the center of the circle. This is still called an inscribed angle. So if this was 60 degrees, this would be 30 degrees. It doesn't matter that that's going through the center. It doesn't matter that the center is on the inside of my central angle. So let's say that this was 140 degrees. This would be 70 degrees. Or it doesn't matter, like I could have a really narrow one where the dot, my center of my circle, is outside of my inscribed angle. It doesn't matter, the same rule applies, and if this is 50, then this is 25. So it doesn't matter where in relationship to the center of your circle your angle is located. It's still going to be half and whatever. As long as this dot right here is on the edge of the circle. Your vertex of your angle has to be on the edge of the circle. Okay, that's the key. A central angle, the vertex is in the center. An inscribed angle, your vertex is on the edge of the circle. Okay, so let's do an example. Let's go down to here, example 1, and they have lots of information for me. They're saying find the measure of angle P. Angle P is this angle right here. And we can see the arc here is 70, and this is my angle that is made from it. And if we pinch, like here's my bow and arrow, if we pinch it back, it's going to be half the angle as that the arc is. So 70 divided by 2 is going to be a 35-degree angle P. Then they're saying, okay, let's change gears, and let's say that this angle right here is 56, and it's intercepting this arc right here, which is PO. This is a typo. That should not say equals 60. We are trying to find the measure of PO. So cross that out, cross that 60 out. They're wanting us to find the measure of angle PO, or arc PO, and all we do is take and double that 56. Okay, 56, if we double it, I think is 112 degrees. So again, it's just the double and the half thing that you are doing, okay? All right, this is kind of a fun concept. So let's take a look at this. And I'm going to be drawing, let's look at just this part right here first, okay? So it kind of makes like a little ice cream cone or kind of a slice of pizza that goes like all the way across the circle, you know, like it's a very generous slice of pizza. And the arc that we're talking about is AD right here, okay? Now, if I draw a different inscribed angle that also has the same crust, AD, it just should make sense that like this angle would be exactly the same measure as this one, right? So like let's say that this was, I don't know, yeah, let's go that this arc measures 90 degrees. Sure. If we pinch that back to this point, this would be 45 degrees because it's half of that. But also, if we look at this one, if we pinch that back, that's also going to be 45 degrees. So it just makes sense that these two angles would be the same measure because they have the same crust of the pizza, if that makes any sense, okay? So, same thing here. If we look at this diagram, I'm guessing they're going to have a solve for one of the angles T. So they're having a solve for angle T, but one thing that I notice is that ST is the pizza crust, right? For this slice, but also the same pizza crust for this slice. So this angle will be the same measure as this one, and I can set these two equal to each other, okay? So 3x minus 5 equals 2x plus 15, and I just do my math. So minus 2x minus 2x. I'm going to add the 5 at the same time. So I've got x equals, this will be 20. And then I've got 2. Ooh. Hold on, sorry.
Fire need at 15th in California. 15th in California, 4428 is on scene.
Okay. That's not our fire. It's a different fire. Sorry, guys. Okay. So we're not done yet because we've got to plug that x back in to solve for t. And x goes here. So 20. And 3 times 20 is 60 minus 5. We've got a 55 degree angle. Okay. Now this one will also be a 55 degree angle if we plug it back in, but angle T and angle U will be both 55. Okay. Let's go to the back side. We're going to skip the proof. Go to this example right here. All right. I like this example, and I'm going to go back up to this concept really quick for this box right here. And this says, remember this. This is important because you'll see this again. Okay. If you have a triangle that is made and one of the sides is the diameter. This is a huge concept. Okay. If one of the sides of your triangle is a diameter, this angle right here is always a 90 degree angle. If the third side or the hypotenuse side of your triangle is the diameter, okay? It's not like over here. It's not like just a regular old chord that we're making an inscribed angle from. Your inscribed angle right here is the diameter, okay? That has to be a 90 degree angle. And the reason why is if we're looking at this right here, this guy right here, what's the measure of this arc? 180 degrees. If I pinch that back, half of that is 90, right? So this inscribed angle right here will always be 90 if the diameter is your third side of your triangle there, okay? So going to this example, they're probably going to have us solve for x and nope, they want us to find angle F. So we've got to solve for x first. But they're doing that concept to you. They're saying this is my diameter, okay? Again, we note that this is not even labeled, but if that's half of the circle, this is 180 degrees. So if we pinch it back, then this has to be 90, right? Like that's my 90 degree angle. But that means that these two, this angle right here and this one, are not equal to each other. This angle and this one are just going to add up to be the other 90, right? All three of them have to add up to be 180. But if this is 90, then these two add up to be the other 90. Okay, so don't set them equal to each other. We just have 4x plus 2 is this guy plus the 9x minus 3. That has to be equal to the other 90 degrees. Okay, let's put that together. So 4x and 9x is 13x. 2 and minus 3 is minus 1 equals 90. Let's add the 1 over. 13x equals 91. And I have to divide by 13. And I have to think for a second. 7, I think. Yes, x is 7. But let's plug back in. They want us to find the measure of angle F. Now, angle F is not going to be the same as angle H, right? Angle F, if I plug 7 in, 4 times 7 is 28, plus 2 is 30 degrees. That's what angle F is. So you could use that then to find angle H. If that's 30, if this guy's 30, then this would have to be 60, right? This is a 30, 60, 90 triangle. But angle F is the only one that we wanted to solve for, so that's 30 degrees, okay? All right, last thing is that, let's see, if quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So the way that this works is that this angle will not be always the same as this angle, although it might be, but these two should add up to be 180 degrees. And same thing with these two, should add up to be 180 degrees. So I won't put little loops around that. But anyway, opposite ones add up to be 180 degrees, okay? So looking at this diagram, we've got some things labeled here for us, I think. This is a little box. I don't know if you can see that very well. And then they have this labeled as x degrees. And then this angle right here is 2x minus 30. And we have no idea anything about A, I don't think. Okay, but one thing that we do know, we just set up here, opposite ones add up to be 180 degrees. So if this has a 90-degree angle in it, then this one also has to be a 90-degree angle. That's just the way that it works, okay? So angle A is 90 degrees. Find the measure of angle A, 90 degrees. Then they want us to find the measure of angle B, okay? So this angle is not the same as this one. Like this is obviously bigger than this one. This is an acute angle, and that one's an obtuse angle. So we can't set them equal to each other, but we do know that the opposite ones add up to be 180 degrees. So 2x minus 30, that's what the top angle is, plus this is just x in the bottom. That has to add up to be 180. Okay, these two angles added together is 180. And then I can just simplify and combine like terms. 3x minus 30 equals 180. And let's add the 30 over. And 3x equals, that adds up to be like 210, I think. And divide by 3. 21 divided by 3 is 7. So this is going to be 70. Okay, now we know what angle D is. Since that's just x, angle D is just 70 degrees. But if we're trying to solve for B, we have to plug that back in for x here. So 2 times 70 minus 30. 2 times 70 is 140 minus 30 is 110 degrees. Okay, now some of you might have solved it a different way and said, if this is 70, then this one has to be 110 because they have to add up to be 180. Rather than plugging it in, you just did it that way. That is fine too. So A is 90, B is 110, and we've solved for everything, and that is all. Okay, so just a few different concepts, but remember this one. This one gets snuck in there all the time. If the diameter is part of an edge of your triangle, then you have a 90-degree angle in there. So don't forget about that one, okay? And then just a few other concepts that I feel like should make sense, okay? All right, on the homework, 9-4, skills practice. I said do the left side. I wanted you to do that rather than doing the odds or evens because like 5 and 6 go together in the same diagram, you know? So it's kind of weird. So rather than doing more work, we're just going to do the left side, okay? Left side and then all on the other side. Sorry, guys. There is a story problem. Read it. It's not hard, okay? Do those. And tomorrow we will build, I think, because track is gone and sophomores are gone. So Tay, you might be the only one first period. And if you are, I won't make you build. You can just have a study hall. But that's what we will do tomorrow. So don't plan on anything for tomorrow for homework, okay?